Welcome dear students, this is Dr. Hadi here and you are watching my English channel, English version with the name of Medical Globe by Dr. Hadi. Today I brought a topic from biochemistry. The name of topic is stereochemistry or stereoisomers in monosaccharides. In my previous lecture I have discussed the classification of carbohydrate, but today we will discuss some of the properties of monosaccharides. So first start with some topics that I brought today. These are you can also write these topics that I am going to discuss with you people. The first one is the stereochemistry, isomers, D and L sugar, optical activity, racemic mixture, asymmetric carbon, chiral molecules, enantiomer and diastereomers. So these will be the topic that will be discussed today. Okay, I want you people to watch the video from the beginning till the end so that you can understand the whole topics. Okay. Before we go to our main topic of stereochemistry, first we will come to isomers. Isomer, what is isomer? Here are two compounds, two organic compounds, CH3, CH2OH, CH3O and CH3. If you see here, because the presence of the OH group in this compound tell us that this is an alcohol, right? This is an alcohol. In here, the oxygen is in between the two methyl group, between the two alkyl group. So this compound belongs to the family of ether, right? Now if you see here, these two are quite different compounds and their structure is different. The structure of this one is quite different from this one, and what is similar in these two compounds is their molecular formula, because we have two types of formula. Any compound, any organic compound can be represented by two types of formula. One is the structural formula, other is the molecular formula. Structural formula is what you can see on the whiteboard, and the molecular formula tell us the number of atoms and the type of elements present in a compound. So if we check here the molecular formula of this compound, you will come to know that there are two carbon, so we will write here C2, and 6 hydrogen, so we will write here 6H6. Only one oxygen atom is there, so we'll write only O, C2H6O. What is this? This is the molecular formula of the alcohol, the ethanol. You can also call it ethanol or simply alcohol. And here again we have two carbons, so we will write C2, 6 hydrogen, H6, only one oxygen, C, that is O. So we have now this one is the molecular formula of ether, and this one is the molecular formula of alcohol. So now you see both the two compounds have similar molecular formula. So if you have two compounds, or maybe more than two compounds which have similar molecular formula but different structural formula, such compounds will be called as isomers. And there are a lot of examples of isomers. This was so easy. You can simply call it structural isomers. Now inside the isomer there are numerous examples. There are so different kinds of isomers are there, and one of the isomer which we are going to discuss in biochemistry is the stereoisomers. So now once you got this, you will be it will be very easy for you to get the stereoisomers. So come here now. Once again, here we have two organic compounds, and what you can see on the whiteboard is the structural formula of the two compounds, right? So if we write the molecular formula of these two compounds, you will come to know that the molecular formula of this compound is C3 because 3 carbon is there. 8 hydrogen is 3, 4, 5, 6, 7, 8 hydrogen and 3 oxygen are there. So this is the molecular formula of this compound, and the molecular formula of this compound is here. Okay, C3H8. Now these two compounds have same molecular formula, just like here. Same structural formula. Like the structure is almost same, but these two compounds are not similar. These two compounds are quite different. Just like these were different compounds, these two are also different compounds. They have different name. If name is not different, at least something new will be added before their name. So such compounds which have same molecular formula, same structural formula, but they still differ in what come here. If you see here, H on the right, H on the right, OH on the left, OH on the left, same. OH on the right side, OH on the left side. So the only difference that we can see in these two compounds is the presence of the OH group. In one compound it is on the right side, in other compound it is on the left side. So such compounds will be called as stereoisomers, and this phenomena of the right and left, the top and bottom, will be called as spatial configuration or 3D dimension. 3D dimension means in x-axis, y-axis and z-axis. If we consider this is the main skeleton of the organic compound, let's suppose it's the main skeleton of the organic compound, carbon, 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 carbon. So in space, the available space, you can adjust the atoms or the groups in various ways. You can position an atom on the right side of the carbon, and the left side of the carbon, on the back side, and on front side, even on top and bottom. So you have 6 categories, you have 6 positions. These 6 positions will be studied in 3 dimensions. We call x-axis, y-axis, z-axis. So if the two compounds differ from one another with respect to the configuration in 3-dimensional space, we call them the stereoisomers. And there are different kinds of stereoisomers that we will discuss in today's lecture. Okay, so this is a very good example of the stereoisomers, and now we will come to the next small topic, asymmetric carbon and chiral molecule or chiral carbon. Let me erase this, because without the concept of asymmetric carbon, we will not be able to understand the remaining topics. That is asymmetric carbon. So here is asymmetric carbon, and sometimes we use this word as well, chiral, chiral, whatever you want to pronounce it. Fluorine. So Just check around the carbon. In both the cases, there are 4 atoms or groups are attached to the carbon atoms. So, but here, if you see here, the 4 attachments, all 4 attachments are different. But in this case, not all the 4 attachments are not different. The 2 are similar. Okay, the hydrogen, 2 hydrogen, there are 2 similar attachments. Such carbon will not be called asymmetric, but this kind of carbon will be called as asymmetric. Asymmetric. That is, I will again write asymmetric. Why? Because there is 4 different atoms or group of atoms are attached to the central carbon. So if the central carbon is attached to 4 different atoms or groups, we will call such carbon asymmetric carbon. And it is so important to know, because it will help us to understand the topics of today, the topics of stereochemistry, some stereoisomers. You will not be able to understand these topics until and unless you know you got something about the asymmetric carbon. And such carbon is also called as chiral carbon or chiral molecule. The whole molecule will be now called as chiral molecule or chiral molecule. So you can call it. If there is asymmetric carbon, there will be the concept of chiral molecule. Otherwise, no chiral molecule, no chiral molecule. So now the reference sugar. Next is the reference sugar. Before going to reference sugar, if I write some complex organic compound, and then we must know either the carbon is symmetrical or not. Let's suppose we have this is 1 carbon and we have another carbon and then we have a 3rd carbon, right? So in this case we have 3 carbon atoms